Hello everyone, welcome to this new tutorial, which is basically the continuation of the previous pump tutorial. And first of all, we'll do the assembly. Right now we are in the assembly module, and we double click on instances and choose the pump part, press on OK. Now again we double click on instances and we choose the gasket. Instance type is dependent, press on OK. So now what we want to do is we want that the top face of the uh, gasket is in contact with the bottom face of the pump housing. So what we do is, first of all, we're going to rotate this, and to rotate we go on to the rotate instance tool, select this, and this is the instance to be rotated. Press on done, and if we choose this edge and put the angle of rotation as 180 degrees, press on OK, we see that it has been rotated. Now the next step is to bring the top face of the gasket in contact with the bottom face, which is not the case right now. And what we do is we go on to the create constraint face to face option, choose this, and we choose the top face of the gasket. Now if we rotate this and choose any of the element face right now, just to make sure that the arrows are in the same direction, which they are not right now. So we press on flip, press on OK, and keep the distance as 0. We see that uh, the gasket and the pump housing are in contact. So you can see this as well. So now as the next step, we want to double click on instances again to bring the cover. So first of all, for the cover, we go on to the instance and rotate instance option again, choose the cover, press on done, keep this as it is, and over here if we put one over here and angle of rotation as 180, you'll see the cover has been rotated as well. Just as we wanted. uh, it's it's not directly in contact, so we haven't applied the face-to-face constraint yet. So during the analysis we'll have a problem. So what we want to do is we want to make sure that the gasket and the cover are in contact, and they are face to face. They have a face to face constraint. So what we can do is we can suppress the pump housing right now. So now we have a better view. So if you go on back to the face to face constraint, and the movable instance is the cover, and the fixed instance we need to rotate is the bottom of the gasket. Need to The arrows are not in the same direction. Now they are. Press on OK. Keep the distance as 0. And now you can see that the cover and the gasket are face to face and in contact. So now we can unsuppress, basically resume. And if we resume the constraint as well, you'll see the pump housing, the gasket, and the cover are in the perfect order, and they are face to face as well. So now as the next step, we need to put on the 4 bolts in these 4 holes. So if we double click on instance, press on bolt, press on OK. You'll see by rotating it that the first bolt is already in the hole, but we need to put a face-to-face constraint over here as well. So we press on this. So since this is a movable instance, the bolt, we press this, and the fixed instance is the bottom of the cover. The directions are the same. Press on OK. The distance should be 0. You'll see that the bolt has perfectly fit into this hole. Now double clicking on instances again, bring another bolt, press on OK. Unfortunately, over here we'll have to go through another step. You can see that the second bolt has also appeared over here. So what we can do is, if we choose this coaxial constraint, and this is the movable instance, so we select this, and this is the fixed instance. Select this, bring the arrows in the same direction, press on OK. Now we can apply the face-to-face constraint. Select this face, then this, same direction of the arrows, press on OK. The distance should be 0, and you'll see that the second bolt has also been inserted perfectly into the hole. Likewise, we'll carry out these steps for the third and the fourth bolt. So follow this same steps again. Choose the coaxial constraint. So this is the movable instance. This is the fixed instance. Flip to bring the arrows same direction. Okay. And now apply the face-to-face constraint. Similarly, for the final bolt, flip, press on OK, and constraint face-to-face. Now you can see that all the 4 bolts are placed perfectly in the holes. And this brings us to the end of the assembly module. Now we'll move on to tree insert meshing. So what we are going to do is, in the model tree, we expand the pump one, and over here if we double click on mesh, so now we are in the mesh module, and now we have to basically create a set over here, and to do that we can double click on sets, and in this dialog box if we choose element over here and put the name as pump mesh, press on continue. So now select the elements for the set appears in the prompt area, and we can just select all, press on done. So now you can see another set has been created. Now we can use the query tools in order to determine the type of the element that is currently assigned to the mesh. So to do that, this is the query information. And in this dialog box over here, if we choose an element and just randomly select any element, okay, I just decide to choose this element, or I can choose this element, whichever I want. So you can see over here that uh, the linear tetrahedron and the type is C3D4. So this element type of the pump housing is not suitable for an analysis that involves contact. So what we want to do is we want to change the element type, and to do that, if we choose this option, assigned element type, and if we just move it a bit over here. So over here now what we can do is if we choose the sets option, And in this dialog box, if we choose pump mesh, press on continue. In the element type dialog box, what we can do is we can toggle on the quadratic geometric order rather than linear. You see it's C3D10, and if we turn on the modified formulation, this is exactly what we want, C3D10M. So after getting this element type, we press on OK and dismiss from here. So now uh, if you want to check, we can go on to the query information again, and if you select this element, randomly select one of them, you can see that the type has changed to C3D10M, which we wanted. So now what we want to do is we want to generate the bolt mesh, and we can basically choose bolt from over here. And the yellow color indicates that it can be readily meshed. And so to do that, if you go over seed, edges, and if we select the entire region, press on done. In this dialog box, we can choose by number option, and number of elements, we put it as 8. Press on OK. So you can see that number of elements have been assigned as 8. Now if you go on to the mesh again, and over here if you choose controls option, choose the region, press on done. In this dialog box over here, we can choose the algorithm type as medial axis, and keep everything as it is. Press on OK and select the regions once again, and just to confirm that the algorithm has been chosen as medial axis, press on OK. Now if we go on to the mesh in the main menu bar again, and choose the element type, select the regions, press on done, and in this dialog box, if we choose the incompatible modes, uh, we'll get the element type that we want, and press on OK. Now we can apply the mesh and mesh part. You can see the bolt has been meshed as we wanted. Next, we have to generate the cover mesh, and to do that, we choose cover from over here, and this orange color indicates that it cannot be meshed. And to do that, we have to go on to the mesh controls again, and over here we can choose uh, the option of element shape option as dead, and press on OK. So now you can see the color has changed to pink, which indicates that it can be meshed with the free mesh technique. Now to assign a global mesh size, we go on to seed part, and in this dialog box we put the approximate global size as 0.35. Press on OK and press on done. So now what we have to do is we have to see the edges, and to do that we have to basically select the edges, circular edges of the bolt holes, and we can select all of them by pressing on shift, this one and the fourth one. Now when we press on done and choose the number, we can choose the number as 8, press on OK, and after this press on done. And next, when we mesh the part, we get the mesh as we want. So lastly, we have to generate the gasket mesh. So we choose gasket from over here, and this color yellow indicates that it can be readily meshed using a swept mesh technique. And to do that, we assign a global mesh size of 0.25. Press on OK. After that, we go to the mesh controls, and we choose the medial axis algorithm. Press on OK. And lastly, we have to go on to the mesh and element type. We select the region, press on done. And over here, what we want to do is we want to change the family to gasket, and we get this uh, GK3D8 node, 8 node, which we want. Press on OK, and now we can mesh the part. So the generating of the mesh gasket has been completed as well. So what we did was we first of all modified the pump housing pump housing element type. Then we generated the bolt mesh, the cover mesh, and the gasket mesh.